Which floor are you going to?
14. 14.
Sorry. I don't understand. Sorry.
Honey, I told you this voice recognition software doesn't understand Vietnamese accent. Try something like American accent. No! 14.
Going to floor 14.
Yay! Weird intro, I know. Anyway, today we're going to create a very exciting data project using a speech recognition API, AssemblyAI, on audio data. By the end of the video, we'll have created a dashboard that visualizes all the key information from the audio content, including automatic audio transcription, sentiment analysis, word cloud for the most frequently used words, automatic content summary, and highlights of most important phrases and words. This audio example is from a recent video by Genji on how he would learn to code on his YouTube channel. It's a great video, by the way, so feel free to check it out. We'll also test the performance of AssemblyAI's API on a pop song. One of my favorite songs is Heat Waves from Glass Animals. I would be so happy if this API can also transcribe this song. That would be very, very impressive. I'll also leave you a challenge at the end of the video to build a dynamic app so that you can practice your coding skills and also develop your own ideas. I'm so curious what you'll come up with. We often think of speech recognition as something that only exists in the past decade when deep learning started to take off. Wrong. Actually, there have been 70 years of intense research into speech recognition using several methods to tap into what we call nowadays audio intelligence. In 1950s, to recognize spoken digits, researchers typically used form and traces of the audio, which basically represent patterns in the audio frequency, which helps us recognize the digits. But these kinds of methods, of course, only work for a simple task with a very small set of data. In 1980s and 90s, increased computational power allows for more sophisticated modeling and training. In these decades, hidden Markov models and later in 2000s, Gaussian mixture models were widely used for speech recognition tasks. Fast forward to 2010s, here comes deep learning as we know it today. In 2020s, where we are now, the cutting-edge AI speech models can create human-compatible transcription. And these models are getting fine-tuned further to be really as good as human or even better. There are many speech recognition APIs available nowadays, and most of them are free for beginners. In Python, there's a library called Speech Recognition that allows us to try out several different speech APIs. However, for today's video, we're using AssemblyAI. It's supposed to be one of the best speech recognition APIs available today, and it's super simple to use. So big thanks to AssemblyAI for sponsoring this project video. This API is completely free to try out for beginners, and only when you want to transcribe more files or use more advanced audio intelligence features, then you can pay as you go. If you want to learn more about their features and offers, feel free to check out the link in the description below. Now let's get started with our project. First of all, to use AssemblyAI, we'll need to create an API key. So if you haven't had an account on AssemblyAI yet, you can go ahead and sign up on the website. No credit card is required, so it shouldn't take you more than 2 minutes. For example, here's my account, and you can find your API key over here. I've also created an empty GitHub repo for our project, and here I've added a few audio files that we'll be working with. One is from the video of Genji on how he would learn to code if he had to start over, and the other one is the song Heat Waves by Glass Animals. Now I'll go ahead and clone this repo and start building the project. As usual, we are going to create a virtual environment to encapsulate all the requirements for the project. Then we'll install a few libraries: JupyterLab, hvplot, Request, word cloud, and Plotly. You'll see how they are used in a sec. Now, if you have an installed panel, then you'll need to install it as well. But please install panel outside of the virtual environment because of some compatibility issues with JupyterLab. Now, from the virtual environment, let's launch JupyterLab and let's create a new notebook, and in my case, I call it Speech Sample App. Now, the first important part of our project is to actually get the audio transcription. So let's go to AssemblyAI documentation, and you can see here basically the walkthroughs of the different steps that you need to do. You can read through all of them if you want, but in our case, we only need to pay attention to the first 3 sections here. So firstly, authentication. We actually have already done that because we have created our own API key, so we can move on to the next part. So submitting files for transcription. Basically, what they are saying is that we can submit the file either via an URL. So if our file is hosted somewhere on a server, on on AWS or whatever, or we can also upload the file from our local computer directly to the API. Well, in my case, I have already hosted my files on GitHub, so I can just use the GitHub URL. Okay, the final step here is to get the transcription results. So how it works is that once you submit an audio file to the API, the audio will be processed and transcribed, and then you can make a GET request to obtain your transcription results. Okay, let's go ahead and copy all these code into our notebook. I'll quickly copy my API key over here. Now let's import all the libraries that we will need here. So I'll import request, the JSON display module to prettify our JSON response later. We import also pandas, numpy, well, the usual suspect, and also the time module. And for visualization, because we are going to have a word cloud on our dashboard, so I'll import word cloud and also the stop words from the word cloud library. You can also import stop words from other NLP libraries like NLTK or Spacey. However, for convenience, I'll just use the stop words from the word cloud module. We will also import Plotly Express. And for the dashboard part, we will use panel from Holovis. And we also import panel extension, which is necessary for some event-driven features on panel. For example, when you click on a button, then something will happen. We also import param and hvplot.pandas. And some other modules are pickle and IO. Let me quickly replace this API token with my own API key. You can either directly define your API key here in the notebook. However, if you want to share this notebook to others, a better way to do this is to put your API key somewhere else. So I will just put my API key in a different folder, a different file. So I'll put it here in the lib folder and I'll call it API secret. Now, if you also add the init.py file, then you can basically import your API key into your notebook. Now, let's try out this code to see if it works. And yes, indeed, we have a transcript response here, and this transcript response basically contains an ID, which is the transcription ID for our file. But this is still the example audio from AssemblyAI, so I'll go ahead and replace this example audio URL and copy the GitHub URL of the audio from Genji's video. But if you're using GitHub like me to host a file, you should also add the query raw equals true. So that basically shows the file rather than showing only the page of the file. So let's try it out. And here indeed you can see the ID of our transcription, and we can use this transcription ID to be able to access the transcription result. So now let's do that. I'll just copy over here the documentation example. Now the result endpoint here is different from the endpoint here. So you can see the transcript endpoint is actually the endpoint that you see over here and slash the transcript ID. So we can quickly do that in Python. We can basically just paste them together, right? So I'll just do that. I'll call it result endpoint equals to the endpoint plus the slash and then paste the ID of the transcript response over here. For the headers, because we already have a header variable here, so I will just quickly rename this one to headers auth and use our own API key here. And if we run this, then after a few seconds, we should see that we get a response, and we can prettify this response by doing JSON response.json. And if you go down here, you can see that we have the text, which is basically the full transcription of our audio file, which is amazing. And I think it's pretty accurate. And now, because we also want to tinkle with some other audio intelligence modules from this API, so if you go down here, you can see that there's a section called audio intelligence. For example, here we have the detect important phrases and words. So basically highlighting the most important phrases and words from the text. We have content moderation if we have any sensitive information within the text, which is probably not very relevant for our case. And then we have topic detection, basically generate the different topics from the text. And we have also sentiment analysis analysis, which is pretty interesting. And one of my favorite ones is audio chapters, so text summarization. So to use these features is very simple. We just need to add those options into the JSON request. So I'll copy the options over here. So firstly, auto highlight, sentiment analysis, why not? Then we have also auto chapters, so auto summarization, and also maybe topic detection. Now let's run this and see what comes out. Oops, we don't really see anything yet. All of them are new. And the reason is, when we run the two cells very fast, basically we are saying you have to give me the transcription result immediately after I submit the file. But in fact, the API do needs a few seconds to process your file. So here in the documentation, they also say you need to keep requesting the results until you see that the status is completed. So we'll quickly fix this part by adding a while loop here. So as long as the response status is not completed, then we will make another request. But we don't need to constantly send the request. So here I'll just wait for 3 seconds before we submit another request. And now let's try it out. And yes, it works. And now you can see here we have the results for also the audio intelligence features as well. So firstly, the sentiment analysis. We also have the auto highlight over here. We also have the auto chapters, and all of that we'll be using for our dashboard. So now we can save this response to a pickle because it's actually a dictionary. This is also nice because next time you don't need to make another API request for the same file. Because if you make many requests, then eventually you'll run out of your trial credits. Now this was fun, and you may already call it a day and celebrate your success. However, to go above and beyond in our project, we'll go ahead and create a dashboard based on the results from our API request. Now, what I'm planning to create is a dashboard that allows us to download the transcript as a text file, and on the right hand side here we show a few different elements. The first chart is for the results of the sentiment analysis, so basically showing the distribution of the neutral, positive and negative sentences. The next thing we might want to show is a word cloud from the text, basically showing the most frequently occurring words in the audio. Next, I'm also interested in showing all the main chapters of the video. For example, we can show the chapter summary together with the timestamp. It'd also be fun to add the audio player over here so that people can directly listen to the chapter. And finally, we can add the auto highlight section over here to show the different words and phrases that are identified as most important by the API. Okay, let's go back to our notebook and see how we can create all these different dashboard components. The first thing we want to create is a download transcript widget. We already have the audio transcript here, right? So now we just need to turn this text into a file object. And the way to do that is to use string.io. And this basically writes the text into a file buffer. And then we can define our panel file download widget, specifying the file as the buffer and the file name as transcript.txt or whatever .txt you like. And if we show this widget, this is how it looks like. If I click on it, then yay, we have a download here, and then this is the transcript of the audio file. Another widget we want to use is the audio play widget. In panel, there's also an audio widget here, so we can just specify our audio URL, and with the name is audio, and the time is basically the starting time of the player head. It's basically the time in seconds. So here, for example, if I start from the 6th minute onward, then if you print out the audio play here, you can see that the playhead is already at the 6th minute. So this is very nice, and we'll use this widget for our auto chapter section. Now for the sentiment plot, we will obtain the sentiment analysis results from the API response. So if we convert this into a data frame, then you can see that we have basically the text of the sentences and the start and end time together with the sentiment category, so positive, negative or neutral, and here the confidence of those sentiment labels. For example, if the confidence score is very close to 1, it means that the API is very certain about the prediction of this label. So yeah, it is a nice indicator for us to see how much you can trust those predictions. Now to visualize this result in a bar chart, I'll go ahead and count how many sentences are in each category. So we'll do the value counts function over here for the sentiment column, and here is the count. We can see that most of the sentences are neutral, and the second most common is positive. Negative is the fewest. So you can see that overall the audio content is pretty positive. And now I'll go ahead and use HVplot to plot the bar chart and create an interactive bar plot. I think it would be fun to also actually see which sentences are positive and which actually are negative. So I'll create a few different data frames here for the positive, one for negative, and one for neutral. And I'll show them in different tabs. And in panel, you can specify the tabs for your visualization. So here, the first tab, you can define it as the current sentiment plot, so the bar chart. And the next tab could be the positive. So we'll show the positive DF data frame. And we also have one for the negative and one for the neutral. So if we show this, we can see that, yes, we have different tabs, and we can actually see, go through here all the different sentences that are in different categories. Moving on to the word cloud component. So firstly, we'll define the stop words, and stop words are the words that are more like you, me, I, to, be, etc. So these words are not super important for the word cloud. Now we want to convert all the words in the transcript to lowercase, because we don't want to have the uppercase and lowercase duplications of the same words. So this is basically what I'm doing. And now we'll join all the words together because now it's in a list. It's very simple to create a word cloud. We just use the word cloud function from the word cloud library, and here we define the background color. We also define the stop words here, and we also define the maximum number of words. So it's basically the max number of words that are on the word cloud. We just put 20 for now, and then we define color map, so just for the color scheme, collocations, etc. And then we just generate the word cloud on the all words variable that we created earlier. We then use Plotly Express to show this word cloud. And here's our word cloud, and you can see that we have the access labels, which is completely unnecessary, so we will remove those labels on the access. This is great, but now I also want to make this word cloud a little bit more interactive. We might want to create a slider to allow users to select how many words they want to show on the word cloud. So that means we want to make the number 20 here dynamic. That means it depends on the value of the slider. So to create this interactivity, I will use Param. Param is one of the libraries within the HoloViz ecosystem, and this is basically a library that controls or handles the parameters, the arguments, and the interactivity within your code. It's actually very simple to use, and I'll show you how. Now let's create a class called controller, and this class is based on the param.parameterized class, and within this class we will create a word slider, and this word slider is a parameter that takes integer values, default as 30, and be bound between 5 and 50. And we will define the step here as 5. Now we want to create a function called update word cloud that takes the parameter number of words, and then we just copy paste all the code for the word cloud in here, and this function return the word cloud plot. Now to make the argument num words here depends on the value of the slider, we'll declare the panel.depends, and this depends on the controller.param.word slider, and we also add what equals to true. The what equal to true basically tells panel that okay, watch for the changes in the word slider, right? Now, when the value of the word slider changes, then the update word cloud function will automatically be called, and that's how the word cloud will be updated based on the value of the slider. We'll actually see how this works later in the dashboard, but for now, let's move on to the next section of our dashboard, which is the auto chapter summary. And this is pretty fun. We'll save the chapters data here from our API response, and the chapters basically includes a list of all the chapters, including the summary, the gist, the start and the end time. Now in this section of the dashboard, we basically want to show for each chapter, we will show the chapter summary text. We'll show also the button that shows what is the start time of this chapter. And then we also want to show the audio player for the chapter. So the first element is the text summary. We will use static text widget from panel, and the value is basically the chapter summary. Let's just do it for the first chapter. And the width is basically how wide the text widget should be. And we have the height policy. We want to fit the height based on the length of the text, right? Some text could be longer and some text could be shorter, and we want the height to be adjusted. If we print it out, we can see the text here. And now for the button, we use apparently the button widget, and the button has the name. We want to put the name of the button as the starting time of the chapter, right? Which is basically the timestamp of the chapter. Now, the name of the chapter is of course a string. The time in the API response is in milliseconds, so we will need to divide it by 1000 and we will just floor the result. And this button has the name 0 because this is the first chapter, so of course it starts at 0 seconds. Now for the audio, similar to what we did before, we will just define the audio widget over here, and we define the starting time as the start time of the chapter. Now I'll go ahead and create a layout for the chapter summary section. So first of all, I'll initiate the chapter's layout variable with the markdown header auto chapter summary. And then for each chapter within the chapter's data here, we will create the chapter summary text widget, the button, and also the audio player. So yeah, and in the end, we just need to append all these elements into the chapter layout. We can play the audio for each chapter, which is very nice. But you might notice that once we play the audio, the playhead is automatically moved away, right? So the playhead is not on the start time of the chapter anymore. So we might want to give users the possibility to go back to the start time of the chapter. To do that, we'll implement a click event for the buttons. So when the user clicks on the button, the audio head will automatically move to the actual starting time of the chapter. Because there are several chapters here, we don't want to hard code, right? We don't want to hard code button 1, button 2, button 3. We want to make it really dynamic. So I'll go ahead and create a class named button audio. And this class basically takes the starting time as an argument. And we'll initiate a few different attributes here. The first attribute is starting time, it's just starting time. The button is the button widget, and we'll use the self keyword here. And for the chapter audio, we also create the audio player. Here's an interesting part. For the button, we will implement the onClick event. So whenever the button is clicked, then we will call the self.moveAudioHead function, and we define the moveAudioHead function, and this function basically set the time of the audio player to the start time. And now within the loop over here, we'll create a button audio object based on the button audio class, and we'll pass in here the starting time of the chapter. And for the button, we will create a button from the class as well, and the chapter audio here, we'll also define it based on this object. Now this will make sure the button and the audio player actually interact with each other through the button click event that we defined earlier. And now if we click on the button of that chapter, we will see that the audio playhead is automatically moved to the start time of the chapter. So this is great. Let's move on to the automatic highlight section. Let's check out the API response results for the auto highlight. If we convert it into a data frame and print it out, we can see all the different text here, which is the phrases or words that are deemed important, and we also have the count and the rank of the words and phrases. Now the count, I can imagine that it's a frequency count, how often this text or these words actually occur in the audio. And the rank, I'm not too sure what it means. I think that it is the rank of the importance of the text. So you can argue that some words or phrases occur very often. For example, they are signs, but it's actually not very important in this audio. Now we see that some texts actually have exactly the same count and the same rank, so we want to concatenate them together. So we do a little group by function here by the count and the rank, and we'll basically concatenate the text together. Now we can see the result here, which is great. So to visualize this information, we can create a scatter plot with the rank and the count on the axis and the text as a scatter plot. Now we can use hvplot to create the scatter plot, and we can also add on top of it the labels for the scatter plot. Now we have created all the little components for our dashboard. Now it's time to put them all together and assemble them into a single dashboard. Now I'll use the fast list template here. You can use other templates as you want. And we have the title for our dashboard, which is the Audio Content Explorer, or whatever you want to call it. The sidebar basically shows some text explaining what this app shows. And here I'll use the fast list template, but there are a lot of other templates that you can use from panel. And here we will define the title for our dashboard, which is the Audio Content Explorer. And the sidebar, I'll just put some markdown, explain what this app actually shows, what is the audio example we are using here. So I'll just add the thumbnail of Kenji's video here. I also put the link to the video and the download transcript button. And for the main body of the dashboard, it's very straightforward. We will have 3 rows. The first row contains 2 columns. So the first column is sentiment tabs, and the second column is the word slider together with the word cloud. And for the second row, we have the chapters layout. So that is the chapter summary section. And then we have the bottom row, which is the scatter plot for the highlights, words. And yeah, this is our dashboard. And looking at this dashboard, I'm particularly impressed by the audio chapter summary, because if we look at the timestamps of those chapters, they are so close to the actual timestamps of Kenji's video. Here you can see that the first 3 chapters have almost exactly the same timestamps, and if you actually watch Kenji's video, you see that the summary of the chapters here are pretty good. Now I also want to see how well this API would work on a song, because this would be a very challenging task. What humans consider music is actually background noise for speech recognition task. Now I'll go ahead and change the URL here to the URL of the Heatwave song, and let's see what comes out of it. Now you can see that it can only recognize 1 or 2 sentences from the song, and because I know this song, I know exactly where this part is. This part is actually the part where there was the least background music. So this part is, I just wonder what you are dreaming of when you sleep and smile so comfortable. I just wish I could give you that look that's perfectly unsaid. So the API could recognize most of this part, but not the other parts that have a lot of drums, music, and sound effects. Now, as mentioned at the beginning of the video, I'll leave you a challenge, and this challenge is to create a dynamic app based on this app. This app is currently quite static because we are inputting an audio file within the app, but we want to create a dynamic app that allows user to input the URL of any audio file they want to analyze, and the whole app would automatically update based on the input file. And for this challenge, I've made a first start. Basically, I have created a class for the whole dashboard, and within this class we have everything from the input file to the download widget to the API calls. And then we also want to add the update functions for all of the charts and all of the elements within our dashboard. So whenever the input file changes, all of the elements would be also updated. So far I've only had the transcript and the download button working, but I think this challenge is very nice for those of you who want to practice your coding skills, also to improve your skill for reading API documentation, because this is a tremendously useful skill to have for any data scientists or data analysts. If you do this challenge, please let me know in the Discord server, as well as tagging me on Twitter, LinkedIn. If you enjoyed this video, please smash the like button and subscribe if you haven't already. Thank you so much for watching. I'll see you in the next video. Bye bye!